MCS-218 Data Communication and Computer Networks. Most expected question. Question number 1. Explain the OSI reference model. The Open System Interconnection Reference Model is a conceptual framework developed by the International Organization for Standardization of Standardized Communication between computer systems. It divides the communication process into 7 layers. The physical layer is responsible for transmitting raw bits through communication media. The data link layer provides framing, error detection, and flowchart. The network layer performs routing and logical addressing using Internet Protocol addresses. The transport layer ensures reliable and end to end communication through segmentation, flow control, and error recovery. The session layer establishes, manages, and terminates session between applications. The presentation layer translates data formats, performs encryption and compression. The application layer provides services directly to users such as email, web browsing, and file transfer. The OSI model helps in understanding networks function and troubleshooting problems and designing inter- interoperable systems. Each layer communicates with its adjacent layer and provides services to the layer above it. Due to its modular structure, the OSI model remains one of the most important concepts in computer networking and is frequently asked in examination. So, everybody should learn about OSI reference model. In short, OSI reference model full form is Open System Interconnection. It has mainly 7 layers. The first layer is physical layer, the second is network layer, data link layer, transport layer, session layer, presentation layer, application layer, and all the 7 layers has different uses. The next is compare OSI and TCP IP models. OSI, open source, and TCP model are the two most important networking architects. The OSI model consists of 7 layers: physical, data link, network, transport, session, presentation, and application, while TCP IP consists of only 4 layers: network access, internet, transport, and application. The OSI model was developed by ISO as a theoretical reference model, whereas TCP/IP was developed by DARPA and is used partially on the internet. In TCP/IP, the session and presentation functions are included within the application layer. OSI clearly separates services, interfaces, and protocols, while TCP/IP focus on practical implementation. The network layer of OSI corresponds to the network internet layer in TCP/IP. The transport layer exists in both models and provides reliable communication. Although OSI is mainly used for educational purposes, TCP/IP forms the foundation of modern networking. Understanding similarities and difference between these models helps students understand how data moves across networks and the internet. In short, OSI and TCP IP models. OSI have 7 layers: physical, data link, network, transport, session, presentation, and application, while TCP only has 4 layers: network access, internet, transport, and application. The OSI model normally used for education purpose and TCP IP model used for various networks and for internet for the worldwide process. Explain different network topologies. Network topology refer to the arrangement of devices and communication links in a network. The star topology connects all devices to a central hub or switch. It is easy to manage and troubleshoot, but failure of the central device affects the entire network. Bus topology uses a single backbone cable shared by all devices. It is inexpensive but difficult to troubleshoot and vulnerable to cable failure. Ring topology connects devices into a circular path where data travels from one node to another. It provides orderly communication, but failure of one node may disrupt the network. Mesh topology connects every node directly to every other node. It offers excellent reliability and fault tolerance but is expensive due to large cabling requirements. Tree topology combines characteristic of bus and star topologies. The choice of topology depends on cost, reliability, scalability, and performance requirement. Network topology significantly influences communication efficiency and network maintenance. Mainly, there are topologies. The name are bus topology, star topology, mesh topology, tree topology, ring topology. So just remember all the name of the topologies and define all. If you learn the name of the topology, you can draw its diagram and define it by your own language. It will be easy for you to write, and it I am providing just a short definition. You can answer more by using your own words. Explain LAN, MAN, and WAN. Computer networks are categorized based on geographical coverage. A LAN, local area network, covers a small area such as an office, laboratory of school. LANs provides high-speed communication, are relatively inexpensive. A metropolitan area network, MAN, covers a city or metropolitan region and interconnects multiple LANs. MANs are often used by organizations and service providers. A wide area network WAN covers large geographical areas such as countries and continents. WANs connect distant networks through leased lines, satellites, or communication providers. The internet is the largest WAN in the world. LANs generally offer the highest speed and lowest cost, while WANs involve higher cost and large transmission delays. These networks categorize help organizations choose suitable communication infrastructures according to their operation requirements. Explain flow control and error control techniques. Flow control and error control are essential mechanisms for reliable communication. Flow control regulates the amount of data transmitted so that a faster sender does not overwhelm a slow receiver. The stop and wait protocol sends one frame and waits for an acknowledgement before sending the next frame. The sliding window protocol allows multiple frames to are transmitted before acknowledgement and increasing efficiency. Error control ensures the transmitted data reaches the destination accurately. Common error detection techniques include parity checking, cyclic redundancy check, the checksums, automatic repeat request protocols, error recovery by retransmitting damages frames, go back and retransmits all frames following an error, whereas selective repeat transmits only erroneous frames. Together, flow control and error control improve reliability and reduce data loss and maintain communication quality. Explain Ethernet and CSMA CD. Ethernet is the most widely used local area network technology and is standardized by IEEE 802.3. It defines methods for data transmission, frame formats, and access control. Ethernet supports high speed communication and is widely used in homes, offices, and educational institutes. Carries sense multiple access with conclusion detection. CSMA CD is a medium access control techniques used in traditional Ethernet. Before transmitting data, a device listens to the communication channels to determine whether it is free. It, if the channel is idle, transmission begins. When two devices transmit simultaneously, a conclusion occurs. CSMA CD Carrier sense multiple access with conclusion detection detects the conclusion, stops transmission and schedules transmission after a random delay. This mechanism reduces conflicts and improves channel utilization. Modern switches Ethernet networks largely eliminate conclusion, but CSMA CD remains an important networking concept. Explain Internet Protocol 4 and Internet Protocol 6 addressing. Internet Protocol addressing is essential for identifying devices on networks. IPv4 uses a 32-bit address format and supports approximately 4.3 million unique addresses. Addresses are represented in dotted decimal notation such as 192.168.1.1. Due to the rapid growth of internet connected devices, IPv4 addresses become insufficient. IPv6 was introduced to overcome this limitation. IPv6 uses a 128-bit addresses format represented in hexadecimal notation, providing an enormous address space besides large addressing capacity. IPv6 offers improved security, efficient routing, simplified header structure, and automatic configuration capabilities. IPv6 reduces dependency of network addresses translations ET and supports future internet expansion. The transition from IPv to IPv6 is an important topic because both protocols consists in modern networks. Explain routing algorithms. Routing is the process of selecting the best path for transmitting packets from resources to destinations. Routing algorithms determines these paths efficiently. Static routing uses manually configured routes and is suitable for small networks. Dynamic routing automatically updates routing information according to network conditions. Distance vector routing algorithms exchange routing tables with neighboring routers and determine routes based on metrics such as hop count, counting information protocol. In a common example, link state routing algorithms maintain a complete map of the network and calculate shortest path using Dikshitra's algorithm. Open shortest path first. OSPF is a widely used link state protocol. Border Gateway Protocol (BGP) is used for routing between autonomous systems on the internet. Routing algorithms improve communication efficiency, reliability, and scalability of the networks. Differentiate TCP and UDP, Transmission Control Protocol, and User Datagram Protocol are transport layer protocol. TCP is connection oriented and established a connection using a three-way handshake before transmitting data. It provides reliable communication through acknowledgements, sequencing, error detection, and transmission. TCP guarantees the ordered delivery of data and is used in applications such as web browsing, email, and file transfer. UDP is a connectionless and does not establish a dedicated connection. It provides faster communication with lower overhead but does not guarantee reliability or packet ordering. UDP is suitable for real-time applications such as online gaming, video streaming, and voice communication. The choice between TCP and UDP depends on whether reliability or speed is more important for a particular application. Explain cryptography, firewall, and VPN. Cryptography is a science of securing information by converting readable data into unreadable form known as ciphertext. Encryption protects confidentiality while decryption restores original information. Symmetric cryptography uses the same key for encryption and decryption, whereas asymmetric cryptography uses public and private key. Digital signatures provide authentication, integrity, and non-repudiation. A firewall is a security mechanism that monitors and controls incoming and outgoing network traffic according to predefined rules. Firewalls protect system from incoming unauthorized access and cyber attacks. A virtual private network VPN creates a secure encrypted tunnel over a public network such as internet. VPNs provides privacy, secure remote access and protection against interception. Together cryptography, firewalls and VPNs from the foundation of modern network security. Thank you.